So first thing first, in the first part, we're going to set up a link to our own project, and we're going to link this architecture model as the base model. Okay, don't open that just yet. But if you want to observe it or see it, um, you're welcome to do so. Just take a look at it. But once, if you are done with viewing that model, you can close it right away. So this is our architecture model, and we're going to develop the structural model. Just a pretty simple one for this building. So as you can see, in this building or in this project, we've got the grid lines and we've got the levels. So when we are linking this model into our own project, we just have to make sure that the grid lines in our project matches with the source model or the base model. Why is that so? It's just to make the referencing the objects easier. Okay, so I'm going to close this project and I'm going to start the structural model. So when you're creating a structural model, thankfully in Revit there has been template for that. So if you start a new Revit project, and I noticed that lots of groups miss this when they're working on the term project because you're supposed to work with a default template, but they decide to use the multidiscipline. That's fine, but when you're working on like specific discipline, you have to make sure that you're using the correct template. So instead of using this imperial multidiscipline, hit the browse button and look for the structural analysis template. Okay, and make sure that you're creating a new project, not a project template, and then hit the OK button. Okay, so here's the Revit project with the structural template. The workspace, the viewport doesn't look any different from regular um, architecture project, but if you take a look at the project browser, the difference will be in how the project browser is set up. You've got the structural plans, you've got the 3D views, you've got the elevations. In the architecture project, um, you just see the floor plans and the elevations. So it's a little different. And not only that, if you're using a structural model or structural template, you can use or you can place the structural components in this project. If you're just using the default template or the architecture template, then you would have to manually load these structural components from either Revit server or from your own custom family. Okay, so just to give you an overview of how we can place structural elements in this project, um, for some reason, the template always have the level 2 active in the beginning, and we don't want that. We want to start from level 1. So make sure that the level 1 structural plan is activated. And then in order to place columns, you need grid lines. So I'm just going to give you place like some random grid lines here. And placing a column is as simple as just selecting the column type from the structural tab, and then you can select the column types, and the sizes or dimensions. Let's say that I want to use like a concrete column 12 by 18 inches. Then um, you need to set up the depth. So that's going to be the height of that column. And typically, when you're placing the column, I like to place them on the intersection of the grid lines. So this will be heavily dependent on your how your structural analysis turn out to be, and they might have different grid line setups when you link that with the um, architecture model. But that's how you place a column, and you can check the 3D model. That's going to look like that. Oh, that's because I set the constraint to level 1 instead of level 2. So as you can see, the way that Revit do the structural columns is going to be at the depth of the column, so the depth of the uh, level of it is hosting, then it's going to add like -9 or negative values to it. So just to make it easier, make sure that when you're placing the column, the base level is set to level 1 and the top level is level 2 and there's no top offset. So set the placement to height instead of depth and set the top constraint to level 2. So that's going to get rid of any message when you're trying to place the columns. So that's how you place a column. Pretty easy. Just keep in mind the placement for the column is a little tricky. There will be some additional extra step that you need to do. But basically, it's similar to placing a wall. Um, you set up the base constraint, the top constraint, and then you start laying down the columns on the grid lines. And there are other system here. If it is like footing, you can have like an isolated footing, for example. When you're placing an isolated footing, you can select the footing types. Make sure that you're on the correct level, just level 1. And if you place that footing under the columns, it will automatically attach to that column. Just like that. And if you check the 3D view, it will automatically place on the base of that column. So for now, just try exploring the beams, columns, um, and the footings or the foundation. So let's say that I want to place a grade beam for the on the first floor. So it will be like selecting the beam type. So I'm going to use the concrete beam. Then I'm going to draw the beam from one grid to the next grid. Just like that. The thing about beam is whenever you place the beam, it will automatically generate the label or the tag. So of course, when you're working on like actual project, this is going to tell you the beam dimension without going to the section view or the beam details. So um, when you're placing the beam, you'll notice that the tag on placement button is automatically active, just like that. Oops. And make sure that the beam goes from um, column to column. So don't draw like a continuous beam from, like say this grid 4-3 all the way to grid 6-3, because that's going to count as just a single beam. Another thing that you need to make sure is typically when you're working on grade beams, they might not be as they might be like thinner than the footings. So we're not using the correct grade beam here, but we'll take a look at our lab assignment, because that lab assignment is going to have the correct beam sizes. So it will be that pretty simple. You just have to make sure that you're using the correct size, the correct dimensions, and set up the grid lines properly when it comes to the structural modeling. Because if you're running a structural analysis, the idea is to define the structure into this beam system and the framing system, and then you put all the dead loads, light loads, run the structural analysis, and make sure that the structure um, can withstand all the additional forces and doesn't collapse on its own. Okay. Any question about this structural modeling? Yeah. Against 900 ohm, you mean the footings? Um, so if you go to the structure tab, there will be several groups. Look at the groups, the foundation group, and if you want to use this isolated footing, choose the isolated footing. Yeah. Okay. We're gonna start with the actual lab assignment after this. So in 3 minutes, we're gonna start with the lab assignment. So we're going to start with linking the model, doing the copy and monitoring. Then we're going to be doing the structural framing. Yeah. Any other question? So make sure that you download it, the base model from the lab assignment. Remember that for the deliverables, you still need to set up the sheets and and all the combining all them into PDFs for both problems. So I will be expecting two PDF files. Yeah, I'll be expecting two documents submitted here, not just one problem for problem number 2, which we are doing today. Alright, let's get started with the lab assignment. So first thing first, before you start on your project, you don't have any reference for the project, where how you're going to place or the beam or the columns or the other structural components. So we have to link the architecture model that we're going to use as our reference. And in order to link the project, we go to the Insert tab and choose Link Revit. And then look for that base model in your computer where you downloaded it. So the file name is going to be TCM 313 underscore base underscore arc dot RVT. Then hit the open button. It's going to upgrade the model to Revit 2026. That's model. Oops, that's weird. I don't think this is the model that I sent today. Hang on. Yeah. What? Hang on. Did you all have this view when you imported the model? Or did you see the architecture model? Okay, let's see what's wrong. No, just pause. All right. So on this level one, let's take a look at the. What was that? It's not that one. Oh, it's wrong one. There it is. Oops. Hang on. Wait a minute. Okay, so here we have to use 24 by 24 concrete columns. So before we place the columns, make sure that we are selecting the correct size. As it turns out, when we bring up the uh, list of the column types, we don't find that. We've got the concrete and the profile columns, but we don't have the 24 by 24 size. So we are going to just pick any of these column types, and we're going to create a new column dimension based on the one that we selected. So in order to do that, just select any rectangular column, click Edit Type. It's going to bring up the type properties just like when you're editing the wall. And in this type properties window, you'll see the dimensions. So that's going to be the width and the length. Just need to type the dimension. So it's 24 inches by 24 inches. Oops, before you do that, I almost forgot. You have to duplicate the column. So make sure that you duplicate the columns. Look at the type line, select the duplicate button, and then you're going to make a duplicate of that and rename it to 24 by 24. Then you can type the dimensions. Then we're just going to place them on every grid lines intersection except on the stairs area. Okay, here's this one. You just put it here and check the 3D view. Make sure that um, columns are placed correctly. So don't worry about the architectural column because the architect is going to make a revision to that. So just place the columns on the grid line intersections. Okay. Do you have any questions on this? Mm-hmm. Okay, so every column will be like at the column intersection except for the one close to the stairs on the southeast corner. So it will be like just place those columns on the building corners. Okay, so after we have placed the columns, let's place the footing. So we're going to use the isolated foundation and just double check the dimensions that we need. So we need the 72 by 48 by 18. That's what we're going to use. Just already selected right here. So we can just simply place the footing at the same position as where the columns are. Double check the um, 3D view. Hey, okay, sorry guys. Remember that even though we have this link visible as underlying or it is a house tone, um, by the end, we're just going to hide these links because when it comes to the structural drawings, we just need the structural elements visible, we don't need the link. Okay, so now we have placed the columns and the footings. We will do the grade beams next for the first floor. So select the structure, select beam to place a grade beam. And based on the structural analysis, looks like we're going to use 16 by 32 inches for the grade beam. So I bet there's a 16 by 32. So we're going to use that as our grade beam. And just draw the grade beam connecting them from column to column. So it looks like the beam is thicker than the footing. If you want to change the size, you can do so, because it looks like our footing is only 18-inch thick. So if you want to change it, like create a new beam type, yeah, you can. Yeah, make sure that they go from column to column. Okay, so that's all you need for level 1. You got the grade beams, you got the columns, you got the footings. So next we're going to take a look at how the second floor or level 2 structure is going to be, because we need to have the secondary beams as well. Those secondary beams are going to be supporting the floor slabs. So we also need to place the grade beams. What? On for, oh yeah, we need this. We need the grade beams there as well. Okay, so I'm gonna go to level 2, but right now we are finished with level 1. So in order to just hide the architecture model, because when we are generating the sheets, we don't want the architecture model to be visible. You can hide it by typing VV on your keyboard to bring up the um, graphics override. So using this visibility or graphics override, you can tailor uh, which element that you want to hide from your view. In this case, we would like to hide the Revit link. So if you go to the Revit link tab, you will see the link that we have here. This is the architecture model. Uncheck that and hit OK. And you'll hide the architecture model. So we'll just be seeing the structural model. So you can place this on your um, sheets. So type VB, go to Revit links, and uncheck the checkbox for TCM 313 underscore base underscore arch. And hit OK. Then that's going to hide the architecture model. Yeah. All right. So we're done with level 1. Let's move on to level 2. Um, and if you see this elevation symbol, just move it away from the building. Okay, now we're going to switch to level 2. So if you notice on level 2, you can still see the architecture model right here. So that's because the visibility settings for in Revit is going to affect just the view that you set it up. So you use hide something in the level 1, um, it's going to be hidden only on level 1, similar to the topo solid. And you might need to do this if you haven't realized that yet. Make sure that you hide the topo solids on every level except for the side view in your project browser. Otherwise, that topo solid is going to show up in all levels. So uh, that's for the term project, but for the um, today's lab, just make sure that you disable or you hide the architecture model once you're done with the structural model. So let's move on to level 2. Place the structure, same columns, dimensions, 24 by 24. Make sure that the placement is set to height and set the top constraint to roof and just place it where at the same point where the level 1 columns are. So you might be tempted to just draw the columns continuously from level 1 all the way to the roof. But there are some benefits from drawing the columns level by level, especially if you want to um, do like model federation later. You can isolate the columns by level instead of by um, the entire column. Check the 3D view. Okay. So, all right. Got all my columns placed. Now, after we have the columns, I'm going to place the level to beam. So I'm just going to give you like an example for this segment. So first I'm going to draw the primary beams, and then I'm going to draw the secondary beams for this um, level. So it's going to be around here. Okay. So I'm going to select the beam, 16 by 32, and draw the beam from column to column. And for your homework assignment, make sure that you have the complete frame. But this is just for an example because we might not have enough time. So here we got the column and the primary beams. What or how do we place the secondary beams, which is going to be like in the middle here? Okay. So we're going to use a function called the beam system. So beam system is going to automatically calculate the spacing of these secondary beams. So we go to structure and you'll see the beam system. We're going to use that. And in the beam system, we just need to select the primary beam where that beam system is going to be hosted. And in order to adjust the beam type, you'll find that option as a property in that beam system. So it's going to be called beam type. And then we just need to select the correct beam size for the secondary beam. So we're going to use this 16 by 24, 12 by 24, like that. And then make sure that the tag on placement is activated. Otherwise, you'll have to manually tag these beams. So click on the primary beams, and it will automatically generate the secondary beam. What? So were you asking about the secondary beams? No, using the beam system, make sure that the tag on placement is turned on, so you don't have to manually place the tags. For the great beams? So with the beam system, it will automatically tag the beam if you enable the tag on placement. If for some reason you forgot to enable the tag on placement on your grade beams or your beams on the second floor, you can just go to the Annotate tab and select Tag by Category or Tag All. So if you want to tag by category, then um, you can just select on or click on the items that you want to tag. And if you don't want the lines to be visible, you can just, hang on, where's the tag? Whenever you're placing a new tag, disable the leader line. Let's see if we can do that. Oh, mine already has one. So tag by category, uncheck the leader line, and click on the beam. But if you enable the leader line, then you'll have the like line extension on the grade beam or the beam. Okay, so that's it for the structural system. Make sure that you complete it because what I showed you just is just like the portion of it. So once you are finished with the level 2, make sure to hide the Revit links again. Then create several sheets as instructed here. Um, Combine the grade beam, L2 beam, north and south elevation, and 3D views into one file. So there will be like sheet for the grade beam, sheet for the L2 beams, and the north and south elevation, and the 3D view. They're all separate sheets. Combine them into one PDF. Same with the first problem. Got have the grade beam, have the L2 beam, have the structural frame 3D view. Combine these into one file and submit both uh, PDF documents into Brightspace. So you just submit the PDF. You don't have to submit the structural Revit model. And make sure to always disable the um, our structural link, including in the 3D view. Type VV, and then uncheck the Revit model or the architecture model. What? And yeah, you have to do this on every view to disable the link. So let me know if you have any question. Uh, Otherwise, make sure that you sign up for the presentation next week, and make sure that you submit all deliverables for the entire project by Sunday.